What we're going to discuss today is the packing assembly on a Fisher E-body control valve. What we have set out on the cart is the plug and stem assembly from a cage-guided Fisher E-body control valve, the bonnet that sits over the top. Normally the bonnet sits over the plug and stem assembly as such. It constitutes the top end of the valve body, and the plug and stem move up and down inside of it. The logistical problem we face with a sliding stem valve like this is how do you allow the plug and stem assembly to freely slide up and down to throttle fluid flow, yet at the same time not allow fluid from the process to leak past that moving stem. As you can see, the hole in the bonnet is quite a bit larger in diameter than the diameter of the shaft itself. So there's a lot of space to fill. We fill that space with something called packing. What the packing does is it provides a fluid-tight seal against the stem of the valve so it can slide up and down without leaking process fluid past the stem. This is what the packing looks like. We have it removed from the valve, and I show it here in all of its glory. I will set that on top of the valve stem. And normally this is encompassed or encased inside the bonnet of the valve. So this is held together under pressure, and these Teflon rings actually grip around the shaft of the valve stem and provide the liquid-tight or the gas-tight, fluid-tight seal we were talking about. To apply pressure to this, another item called the follower slips on top of that, and you have a packing flange that goes on top of that. This flange normally drops down on top of those holding bolts on the bonnet. Right here you see it removed from the bonnet so you can see how everything works inside. There's a shoulder on the inside of the bonnet that the bottom guide rests on, so as you tighten down the packing flange, it applies linear force to the packing rings themselves and compresses the spring. And by compressing those packing rings, what it will do is actually squeeze the Teflon packing in on the outside diameter of the stem and thus provide the fluid-tight seal that we're looking for. This particular packing assembly has a coil spring built inside, and they refer to this as a live-loaded packing. What that means is that when we compress this, the spring actually gives, and as the packing wears and as the valve heats up and cools down, the spring is able to take up any slack that may otherwise develop in the packing assembly. Not all packings are live-loaded. Some are solid with the packing material. In fact, there's a wide variety of packing arrangements you can have here, depending on the application, the process fluid, the temperature range that you're dealing with. We're just looking at one example of a sliding stem valve packing. But that's the basic idea of it. The sealing action, in this particular case, comes from the Teflon rings. As you can see here, the rings have a shape allowing them to fit together quite neatly and lock into place. And as those rings are compressed around the shaft, what they do is they squeeze the outside diameter of the shaft and form the fluid-tight seal.